Programming languages. Arrays. Arrays are homogeneous. Some languages require the index to be an integer, but most languages require it to just be any discrete type. So any scalar, you have floats, integers, doubles, whatever, right? The syntax and operations allowed to be done on arrays. Well, for most languages, the only two that are allowed are selection of an element and assignment. In other languages, such as Ada and Fortran, you're allowed to compare two arrays for equality. So if you have an array of 1, 2, 3, 4, and another array of 1, 2, 3, 4, you're allowed to compare them to see if they're equal or equivalent. There are 4 array types: static array, semi-static array, semi-dynamic array, or as it's put here, semi-dynamic array, and dynamic array. They're all implementation of arrays. Static array. So the range is statically bound, the storage allocation is static, and they're efficient. Semi-static array. The range is statically bound again. However, this time the storage allocation is done during runtime. This is space efficient over static arrays. Semi-dynamic arrays. The range is dynamically bound. Storage allocation is done during runtime. Range will be fixed for array's lifetime, and they're flexible. And finally, dynamic arrays. Range can be changed anytime. This is the max flexibility you can have on an array. Memory layout. Arrays are stored in contiguous locations. However, multi-dimensional arrays, they have a couple ways of dealing with it. So if you had a one-dimensional array, there's going to be memory location 1, memory location 2, memory location 3. Multi-dimensional arrays, well, they can have many dimensions. For example, if it's 2 columns by like 2 rows, like a matrix, we have row major, column major, and a third less common implementation of storing them in memory. Row major. Row major stores elements in a consecutive location in memory with a differing by one subscript. So it's going to change the row instead of the column. So if you are at 2, 4, the next element in memory will be 2, 5, right? Column major is the opposite. So if you're at 2, 4, it's going to be at 3, 4 next. And then the third lesser common implementation is row pointer layout, where the rows, well, the main array is just a pointer to other arrays, which are the rows. And this creates an auxiliary array of pointers to the rows. And that is the end of